Okay, well, good evening everybody. Thanks Simon for the introduction. I was at Acorn Computers, or CPU Limited, and I was there from the beginning. This talk this evening is very much my personal memoir of things that happened to me, things that happened at Acorn in about the first 10 years, the first half of the company's existence. I've got quite a few slides to look at. Unfortunately, we can't be together this evening, so this is going to be over Zoom. So what I thought I'd do to try and make it interactive as interactive as we can is to have 4 breaks for questions. And if you look at the agenda here for my talk, it's you can see that the first part of the talk is about my backstory as far as the system run. So a quick break for questions that are relevant to that part of the talk alone. Then I'll follow up a quick talk about Acorn systems and the atom. Again, a pause for questions. Then the meat of the talk, perhaps the BBC Micro, expect more questions then, and after that a short section post BBC Micro for me and my last couple of years at Acorn, and then we can have a final question session when anything you like can be asked. My backstory to all of this is that I was born and brought up in a village a few miles from Cambridge, and I went to the local grammar school. I was very interested in electricity and electronics in my early teens, and I was building radios, first with valves and then transistors and other things that you could, components that you'd buy from a shop in Mill Road in Cambridge called Harry G's. I also got lots of parts by stripping down old radio sets and sorting and storing everything down to the last 6BA nut and screw. And valve numbers like 6V6 and ECC82 still trip off my tongue after all these years, as do transistors like OC44 and OC71. I even built some of Clive Sinclair's kits, and I read magazines like Practical Wireless, and thought one day I'd become a radio ham. And then in my mid-teens, I got involved with the local disco and became the Sparks, wiring up decks, sorting out lights and building mixers and transistor amplifiers and the like. And I reworked the mains transformers from old valve radios by removing and rewinding the secondary to get the 30 or 40 volts you needed for a transistor amplifier. I used to etch my own PCBs with resist and very smelly ferric chloride. All of which gave me a really good practical introduction to electronics and stood me instead for my first job interviews because I didn't go to university. So this is my employment timeline, just about 50 years of it, starting bottom left and going around clockwise and ending up at ARM, where the last thing I did was procure a tea mug before I left. My first job was as an electronics technician at the university's Department of Physics, the Cavendish Laboratory. And they were very good. They sent me to the local technical college on day release, and I studied engineering all the way through to the CEI Part 2 examinations, the equivalent, indeed the metric for an electronic engineering degree in those days. I worked on lots of projects in the Cavendish, including building digital interfaces for crystallography apparatus to connect it all up to PDP-11 mini computers. We were effectively an electronics jobbing shop, and at one point I designed and built a system that helped with, it was a mixed signal digital and analog system that helped to acquire high-speed camera images that one of our research students wanted to use. That guy was Herman Hauser. I moved on in '76 to be an electronics design engineer at the Pi group of companies, first at Pi Unicam, working on scientific instruments, atomic absorption spectrophotometers, and I gained early exposure to Intel microprocessors going right back to 4004 and 8008, and then 8080 and Z80. I designed an interface to the Commodore PET. One of our US sales guys bought over a PET, possibly the first one in the UK, and it ended up on my bench, and I got one of our instruments connected up to it so that we could run through all the measurements that were being made and do the appropriate calculations to work out the chemical composition of the samples. And then after a couple of years, I transferred to Pi TVT to work on television studio equipment, where I was responsible for a complex digital pitch and noise reducer in collaboration with the BBC's research group at Kingswood Warren in Surrey. And in that year or so, I learned a lot about television technology, which of course came in useful later on in a way I couldn't then have foreseen. Well, meanwhile, Herman got in touch again, and he got involved with Chris Curry at the newly formed Science of Cambridge, and they were looking for help with the MK14 and another project to put microprocessors into gaming machines. So I met Chris and Herman, and I believe Steve, and then we met up over the 1978 bank holiday in the beginning of May, first in Science of Cambridge's offices in 6 Kings Parade, and then again at Herman's house where he was living at the time on Grange Road. And I distinctly remember being in Herman's front room with Steve, and we took the back off an Acorn gaming machine and stared inside it for the first time, wondering what we, or rather what Herman, had got us into. That was a typical of way of how many things got started. So Herman and Chris had set up Cambridge Processor Unit, landed this consulting project. I have no idea how, for the gaming industry. I guess they were trading on the university in the way that other consultancies like Cambridge Consultants were doing. Trading on the university name and reputation and so on, but they got this consulting project to put microprocessors into Acorn's fruit machines, because there was already a trend starting in the industry where conventional just electromechanical machines that relied on loads of relays and timers were quickly going to become obsolete, and any one-armed bandit gaming machine company that wasn't into microprocessors was going to be a little bit like a horse and cart versus a motor car, you know, and left behind in the dust. So they wanted to move fast, and we were available to do that. Of course, using a software-driven system would let them have much more sophisticated gaming, and the machine would be much more flexible because you could reprogram it and then just change the front panel for different games and different markets, clubs versus pubs and so on. So Steve designed the processor using 2 National Semiconductor SCMP or SCAMP processors, and I designed pretty much the rest of it, such as the input sensors for the switches, drivers for the lights, and some quite neat triac drivers for the reels and other motors. So whenever we needed to drive anything electromechanical, one of these triacs would be fired up. There was an optical isolator between the triac system, which is all 50 volts AC, and the digital system on the microprocessor side. And the triacs would only fire as the AC was going through 0. So I had 0 crossing detectors there, which minimized all the switching noises, all the relays and reels clacked around. We got the PCBs laid out, built the prototypes and so on. ACE had originally thought they could carry on using all their original wiring looms as well, but we quickly realized that wouldn't work, because hence the use of the ribbon cables for the clean side of the machine, switches and lights and so on. So this project ran through 79, probably into 1980. Other people got involved to write software for it and also make simulations, I guess on Titan or the IBM 360 at the university, so ACE could predict the payout percentages. I do remember during this period I was doing most of this moonlighting, or at the beginning at least, while I was still at Pi TVT. A company in the Midlands called Maygay Machines found out about me somehow and offered me a huge salary to move up to them, but I turned that down for various reasons. And secondly, I do recall, amongst many trips after I joined CPU, many trips down to ACE in South Wales, where I do remember distinctly one Saturday where I had to spend the entire day feeding the machine, taking the money out of the back, putting it in the front again, and recording the results for a report that ACE needed in order for the machines to be sold. And that was on the Cup final day in May 1979. And I don't think I've put a penny in a gaming machine ever since. And then concurrently, possibly a little earlier, Chris and Herman also wanted help with Science of Cambridge's MK14 project. Now, this was the second iteration of this project. The first iteration story is recorded on, I think the Register has got a page devoted to it. Steve Ferber and I knew nothing of that background. To us, we came to this fairly cold. We were taking over a design that was derived from a National Semiconductor Application Note for the SCAMP. Steve prototyped it on Veriboard and then handed it over to me to essentially, shall we say, production engineer it and implement the first printed circuit boards. The circuit diagram is shown here in this slide, and you can tell it's one of mine because I had a habit of drawing circuit diagrams, logic circuits that days, with the Boolean equivalent of a TTL or CMOS gate when it suited me. So if I was thinking through how a circuit worked, what needed to be low before something else would go high, a 2-input NAND gate, which would be a quarter of a 74LS00, I might draw instead as an OR gate with both inputs inverted. So that's the Boolean equivalent. But from my point of view, that meant that if either input went low, then the output would go high. And you can see I've drawn that kind of thinking in a couple of places on here. It used to drive the draftsman at Pi Unicam mad, but that's another story. Then I laid out the PCB and built up the first boards in the back room of my house. And I did this in the evenings and weekends while I was at TVT and got paid for it, which was helpful as we just got married with our first child, had a mortgage and so on. So anyway, I wasn't happy at Pi TVT for various reasons, and Herman wanted me to join CPU. I had met Steve, and Sophie, of course, was enthused about microprocessors, way back from using the Commodore PET and other things. And so I joined CPU Limited in 4A Market Hill on the 5th of February 79 as the first employee. And we got various things done almost immediately, including getting the System 1 out to market based on Sophie's Hawk concept. I'm not sure of the precise timeline here because Steve has said elsewhere that Sophie proposed the Hawk the previous Easter. So there must have been quite a bit of prototyping going on through that summer and autumn of 1978. And I think that sorting out the cassette interface design and so on may have taken us a while. That circuit originally came from Steve. I have it somewhere sketched on graph paper, but it's not quite the same as the final one. So I think quite a lot happened on that. And I suspect I was involved to a degree in the autumn and over Christmas 78. But certainly I think I was instrumental in finalising the product and getting it out to market in the early months of 1979. I think everybody knows that Herman had met Steve and Sophie at the University Processor Group previously and got them both engaged in his thinking and the company that he and Chris wanted to build. As I recall, Sophie was finishing her degree and became a full-time employee later in 1979, whereas Steve had research commitments in engineering and wouldn't join full-time until the autumn of 1981 after he finished his PhD. It was a risk on my part to join this fledgling company. I was quite nervous, but excited about what we could do. It's since occurred to me that Herman was probably a bit nervous as well, because I'd made it clear then I needed to get paid every month, even if we weren't making any money. Sophie, of course, wrote the software, as we all know, utilising the efficiency of the 6502 instruction set to the full. It fitted the ROM exactly, although she knew where she could recode a few instructions and find a spare byte or two if it were needed. In fact, I think she set competitions for other people to try to find out where those spare bytes might be. And the only printer we had at first was a little heat-sensitive paper printer which printed out the listing for the monitor here, which you probably can't read. I have this and other artifacts, by the way, Jason, that I'm going to put in a box and bring along to you shortly, because we need to declutter some of this stuff. Here's the circuit diagram for the keyboard, cassette recorder interface, and one of the first adverts in practical electronics, selling direct off the page. As somebody said earlier, well, Hugo said earlier, cash flow was positive because customers sent the money with their orders, and then we get the bits together and ship within 28 days. This was common practice in those days. Sinclair had been doing it forever, and we followed on with that. I do remember a day when our secretary, we had a secretary, put a telephone call through to me in my office upstairs. I took the call. This happened quite often. And it was from a guy in some large company. He'd seen, he was in the purchasing department or something, and he'd seen that they'd ordered a computer from us and we were going to deliver it shortly. And his question to me was, how many men and what equipment would he need to have ready to unload it? I didn't really know where to start, and I think he probably thought I was mad too, but we all fell about laughing at that one when I shared it with everybody else later in the day. I think, as is evidenced elsewhere, you can see that I wrote the System 1 manual and drew all these pictures and so on. I spent, it's quite typical for the first couple of years for me to be the scribe for Sophie or Steve, really, extracting from them and hassling them until we had things right, and then, you know, being that bridge between getting the ideas and concepts to solidify and get documented and then turned into circuit diagrams or documentation and so on, which inevitably often meant that I ended up proposing the final solution and other people saying, yeah, I think that's going to work, you know. I've got lots of data books. We have to remember there was no internet or email in those days. We all had shelves full of data books, textbooks, magazines, and we'll have the first break for questions very shortly on this section. And I've also got my diaries and lab books still. A lot of it's scribble, and a lot of it's missing. I wish now I'd taken more notes of what we did, and because I didn't know then how significant, of course, our work was going to become in the future. And you can see both my CPU Limited and Acorn computer business cards on the covers of the books here. Here are some typical pages from one of those notebooks. I don't know how well you can read this. I hope you can see some of it. The one on the left has me thinking, probably in a meeting, notes from a meeting about the SAA 5050 teletext chip costs and so on. I think it was me that first identified this as a good option for our video boards. First of all, one of the Euro cards, because you've got a cheap color character set for teletext and dial-up modem view data services. The 5050 was part of a set of chips from Mullard, later part of Philips, and with that you could build a complete teletext decoder, and I'd seen all these chips previously at PyTVT when Mullard sales reps had come in to promote their wares to TVT engineers, so I was familiar with all of these things. And these pages made me smile. Remember, we didn't have spreadsheets, so if I wanted to draw a table and work out the drive currents on the bus for building systems, you know, you sat on with some ruled paper and added things up by hand, and other calculations required a slide rule. or an HP 35 calculator. So there's lots of this kind of stuff in my early lab books. And with that, let me pause for breath, and Jason, you could ask the first one or two questions if anything's come up that relates to that first section.
Hi, yeah, we got a couple. First question that's come up from Jonathan is what happened to Mark 1 to Mark 13? As in, I guess a reference to MK14, right?
Oh, I have no idea. Why was it MK14? I don't know. I've never known that. I don't think I ever knew it.
Okay.
Whether Chris Curry just thought that was a catchy name for the product. You could check on the article in the Register where Paul Williamson describes his involvement in the first iteration of the project. Not Paul, Ian, Paul's his son. Ian Williamson describes his work on the first iteration of the project, which in the end was not the version that went to market. See if there's anything there, but I've never known.
I know the answer to this. Chris Curry reveals it. I think it's in his talk that's on the Centre for Computer History website. It's simply that there were 14 key components on the board. So it was the MK14.
Okay, that's interesting because that name must have been given to it before Steve and I finished designing it. But yeah, it's as good as any. So it works as a product name, I think, for it, and at that time.
The other questions that come through are perhaps related to a little later in the talk, so I might store them up for them. There's I'll read out this one that by its own from Chris, who admits it's tangential, but he said, I'd love to hear Chris's observations about the Olivetti Active Badge and the ultrasonic version I believe got nicknamed the Active Bat. We used it at Online Media, and it was fun, but not without foibles. So,
well, that's really off topic for this evening, but we could pick that up in another fireside chat or something if you wanted to. I was certainly a user of Active Badges. They did useful things, and in fact, in my time at the Olivetti Research Lab, I wrote a Windows PC Windows application to display the badge people's database on a PC. Instead of the Unix systems that the rest of the guys were using, and that got us got good interest from the main Olivetti group. So that was a useful piece of work.
I think we've got one more question that's just come in that's relevant, and probably the last one, I suspect, before continuing the presentation. So Andy asks, for the System 1, what were people using it for? An early control MCU or just a learning aid?
I suspect not very much. Learning, a lot of people wanted to experiment with microprocessors. The same, probably the same audience that a year or two later was buying BBC Micros or Electrons. They wanted to get their hands onto a microprocessor system and see what they could do with it. Of course, the answer was not very much. There was a general purpose I/O port on it, so people may have been flashing the odd light with it or connecting it up to a doorbell or something, but in truth, it wasn't very capable until you extended it into a system, which of course was what we set out to do fairly quickly. So I think it was just people who wanted to learn to write machine code. So as I said, we fairly quickly moved into systems. Here are 4 circuit diagrams. I've actually got what might be a complete set of literature of the early all the early system boards and the sales literature here, all the circuit diagrams, and most of which I drew. Jason Fitzpatrick, that is, if I fall under a bus or something from now on, please come round and claim this from my children before they burn it or something. Many of the Eurocards we designed through 1979 and 1980 owed something to Steve's homebrew computer. I'm sure you're all familiar with that, and he's presented on that as well. But none of them were direct copies of what Steve had built. I did a great deal of, shall we say, finessing the designs, changing parts of them where appropriate, choosing the components, finalizing the circuit diagrams, rationalizing the TTL logic to, minimize the number of packages and move gates around until it worked. Sophie had a hand in things too. Fairly typically, she'd wander in and out, look at that and say, I don't think that's right, you should do it like this. And of course, that was normally correct. And wrote the initial software for systems. Very early on, we had a basic and an operating system and so on. We used a local contractor called GW to do the PCB layouts, so I didn't have to do all those myself. And right from the beginning, I designed a kind of a product part numbering hierarchy so that we could keep track of things and number all the drawings and all the parts and so on. And this early discipline paid off quite quickly as the company grew. You may have found early versions of these circuit diagrams with an alphabetic issue, A, B, C, and so on. That would indicate the development or pre-production document or PCB layout or something. And then you would switch to a numeric issue 1 when something had gone into production. And that was the same system that I'd seen used at Pi Unicam and at Pi TVT. So I just carried on that same issue or revision numbering system, numbers and letters system for the hardware. And an answer to some questions I've seen come up in the past on various threads. Do note that issue numbers don't necessarily track each other. What I mean by that is you could have a printed circuit board that had got to issue 3, but the circuit diagram it would be implementing would still be at issue 1. But what would happen is that there would be 2 more iterations of the PCB layout, maybe the first one to fix a bug on the layout, a tracking error, and the second one maybe to ease production, because when you soldered the PCB, you got solder bridges, and so you moved some tracks apart. So you can't assume that an issue 3 circuit is an issue 3 PCB and so on. And that carries on right through all of Acorn's products. Elsewhere, we would have what we would call a build standard file, where we would track all of the issues of the different pieces of hardware and their implementations, so that we knew what went with what and what any particular serial number had been, what its build standard had been at the time. But that was all part of the engineering documentation processes. So, we assembled the Eurocards into systems as well as selling them separately. On the left is the cover of this brochure, this folder that we had, that we used to hand out at trade shows and so on. And there were more and more loose insert pages that would go inside as we had more and more cards. And I think I probably wrote most of this technical blurb that's in all of these things. Yeah, that's what would happen, and that was all done on the editor, which came from Steve first, and then Sophie improved it. So we were always eating our own dog food, as people say. We were, all of this stuff was actually written on our editor, on our operating system, using our, by then, Daisy Rule printer and so on. So, there were no third-party computers in the building. Couple of magazine adverts here. I expect you've seen some of these. And on the right, something I found stuck in one of my notebooks. It's a telex message telex was mentioned earlier as well by Brian. It's a telex message giving us the timing data for the triple rail 16 kbit DRAMs we used on one of the Eurocards. And you can see down the bottom that it was given to me when he visited, which he did regularly, by Robin Saxby, who was our account manager for Motorola at the time. And Robin, of course, went on to become the founding CEO of ARM. That was typical. We made friends with people like Robin in a lot of the companies who were selling us chips and certainly, supplying things to us in some way. These people, some of them became, part of the future of Acorn and ARM. And I think even early on, they sensed the excitement and potential in Acorn and what we could become. And I always took the attitude that being open with them and helping them would help us, rather than adopting traditional, more confrontational behavior that they'd see from purchasing departments in larger companies. So, we were very open. We had very good relationships with all these guys, and they all bent over to get us data books and samples and the things that we wanted. Another example of that was a guy called Sandy Dow, who was our first sales director. He joined us from National Semiconductor, where he'd previously been our account manager. And Sandy, in the early days, was the sales director when we started moving the atoms. So System 3, 4, and 5 came about in 1980. More notebook pages here. There are many pages like this showing me thinking out loud almost about how we'd fit the cases and frames together, what parts we'd order from, I think it was Vero Rack, most of this stuff, how we would organize the cards, the card frames and so on. We spent a lot of time evaluating different floppy disk drives. Pretty much all the 5 1/4 inch floppy drive vendors came and brought us samples to test. We have some favorites, early Shugart drives, single track, I remember. Asif, I think, drives and so on. Some were good, some were not so good. But we used to buy 5 1/4 inch floppy drives in, probably 10 at a time as we needed them. And the company got very busy. We were buying all the parts we needed to produce these things. Lots of people. Market Square became very busy. We were packing kits, processing orders. Some products were assembled and sold finished. We used a local small electronics company called RH Electronics at French's Mill, which eventually more or less became part of Acorn. And there were lots of other people helping to develop, test, and generally get things done. Some people I knew, some people out of the university, and then as business grew, we took on other people, staff in the Market Square and RH. One person I remember really well was a guy called Colin Priestley, who was with us for a few years in the early days, helping get things done, helping get things delivered. Colin was just ever cheerful, and you could just rely on him to get stuff done, packed and shipped under pressure. And you go to Colin and say, I don't know how we're going to get this stuff done today, and he'd say, no problem, leave it with me. And things got done. And there was lots of that can-do attitude. So overall, we developed and sold about 17 Eurocards, I think, plus a backplane, a keyboard, and a lab interface panel. Lots of companies were picking up the systems for industrial control and lab apparatus, and universities were using them in experimental rigs and so on. And we had good relationships with a lot of those customers as well. And some of the things we developed were based on their requirements. Looking back, looking at this price list, I actually wonder if we sold these things too cheaply. But we were keen to drive sales and keep things affordable for hobbyists as well. So maybe the pricing was right, I don't know. But more important, I think, is the way these systems and the software, the text editor, the disk filing system, and all of these things gave us the technology platform to move forward with the Atom and then the Proton. And of course, they served as our development tools. We built our own EEPROM blower, the in-circuit emulator, which we used a lot for debugging other products, and these, all of this technology. It's almost as though we built the things we needed, and of course they were the things that everybody else needed. So it became very much a virtuous circle as we developed all of these things. Here's some pictures from trade shows in the early days. These are pictures I've got taken, unfortunately, on a very poor quality camera. The one on the top left is at the Alexandra Palace, and I think it's possibly the first trade show we went to. You can see Herman standing, and then further back in the background, David Johnson Davis. And Compec, very big show in what I think was Olympia. There's a Presto demonstration on the top right, and a fancy stand with lots of Acorn atoms on, down on the bottom right there. And you can see how our branding looked in those days as well. Quite different to how it ended up later. And here's a couple of pictures of my office. So, and this was it. When I wasn't on the phone or at my drawing board, which you can't see in these pictures, but it's just to the left of my desk. I was using the computers or plugging things in or soldering things. It was just doing everything. I wasn't the only person doing these things, of course, but most people's desks look something like this. Perhaps mine was more extreme. On the right, which is also the other corner of my office, the other side of the drawing board, you can see there's an atom undergoing some major surgery. And underneath that thing with the 4 red bits on, that's the real, a set of reels out of one of the gaming machines. So that was still going on as well at that time. And then the atom happened. Christopher Curry was keen for us to have a more consumer-oriented product. He bought Nick Tupin to focus on designing it. And Alan Boothroyd, a local industrial design consultant, designed the plastic case for it. And the key thing about the Atom was it has a full-size keyboard. And that was the thing that we all agreed on. We'd all learned that to do anything serious with computers, you couldn't sit there tapping it away at a membrane keyboard. And Chris's experience with the MK14 and elsewhere, what he saw happening at Sinclair, we all knew that would be Acorn's differentiator from many other small computers at that time. Nick Toop did the initial circuit design for the Atom. It's his product, but I got involved, as you can see here, actually starting to again extract the design, work out what bits were actually finally going to go in it, getting the final circuit diagram agreed. Kind of almost forcing Nick to make final decisions about, so are we doing it like this or like that? We need to decide, we need to get on with this. And, so I had quite a hand in, shall we say, the final stages of design, and then getting it into production. And we sold kits, and we also had a company in Hong Kong called Wong's Electronics who assembled finished Atoms as well. And, it went on to be a success. Very successful product, eclipsing the system straight away in terms of importance. I think David Johnson Davis' contribution was key, getting the games, of course, so people could do fun things with it, and writing a really, really good user manual, Atomic Theory and Practice. And yes, some of those were sold to physicists who thought they were about atomic theory, and it really did happen. But the product was very successful, and there's the picture on the stairs again that we've seen earlier. And then we started work on Econet, or AtomNet as it was first called, as you can see on the left-hand notebook page. Andy Hopper came in with the idea. We discussed this earlier. He was working on Cambridge Ring and other networking technologies in the computer lab. They'd also studied Ethernet quite seriously and understood the difference between fast slotted rings and broadcast networks like the Ethernet. CS, MA, CD, carrier sense, multiple access, collision detect networks. Andy said, well, if you want to build a lower cost network to connect lots of computers easily, then it should be more like the Ethernet. He came in with some sketches of circuit diagrams for line drivers and receivers and how it might work. And as you can see on these notebook pages, you know, we started picking those apart and saying, well, what's going to work in practice and what are the right components to use? A guy called Lawrence Hardwick had joined us by then, and he took up the challenge of sorting out the line drivers and the receivers, clocks, terminators, so that we could spend a lot of time, you know, with reels of cable to simulate a long Ethernet with a number of devices on it, looking at the scope and the eye diagrams to make sure we'd still got clear pulses. I did some of the logic design. I think it might have been me that chose the 6854 to be the basically the UART and framing chip. I think Andy just came in and said, well, you squirt a bit stream in here without, you know, defining how it would be framed. And so we picked up the 6854, and the default was framing as that did. And it was a very big success. Lawrence worked very hard bringing up installations in schools. It made the Atom successful. Another colleague who didn't join on the staff but was always a contractor, Kim Spence-Jones, helped with some of it as well. And later on, he formed his own company, SJ Research, to make and sell these file servers and so on. And then we also had some involvement with the Cambridge Ring, a high performance network, and Mike Muller came on board to work on this. And initially it was a company done by a company called Orbis, but we folded that into Acorn Computers as well, and hence Andy Hopper became a shareholder in Acorn as opposed to just Orbis with Herman. But we more or less discontinued that work a year or so later as too many other things became important. So this was the world around us while all these things were going on. Questions on them after this slide, by the way. Hugo talked earlier about the building, so I needn't repeat that. The entrance beside the electricity showrooms, the building at the back with the quaint windows. We were busy solving Rubik's cubes, for which Sophie wrote a program to solve them in 3D on the screen. Listening to Pink Floyd. We had French's Mill, where RH Electronics is, that's the windmill. We also had offices in Bridge Street because the Market Square filled up. So Chris and Herman and Sandy Dow and other people moved up to Bridge Street just before Magdalen Bridge there, which was where they were. Lunch in the copper kettle was quite traditional. That's where, at least in the early days, Herman and Sophie and myself would go for lunch, and Steve would come up Trumpeton Street from the engineering lab to meet us, and the four of us would have lunch, and then we'd entice Steve back to the Market Square to do some design work with us for an hour or two in the afternoon. We all know that System 1 was powering the computer on the Blake 7 spaceship. And on the bottom right, the other important thing for me was that my daughter Lisa was born just about the time, or pretty much at the same time, that we were discussing what the Proton was going to look like. So let's have, again, a burning question here, but I'm going to run out of time on this, so we better limit it to just one question if you can see something there, Jason.
We got one question from Andy again, and this is there any chance of resurrecting the Atom case, do you think? Does anyone hold the injection molds, for example, or drawings for the case?
Right. The drawings for the case probably went, I'm pretty certain that the case was moulded in Hong Kong by Wong's Electronics. That is now a company that's moved into China. It's I think one of the largest, if not the largest, privately held electronics manufacturing companies in the world. And I believe the founder's son, Ben Wong, who we knew might still be around, but whether they would have that, I wouldn't think so. I wouldn't think so.
And the drawings, do you think they might be hanging around anywhere?
From Alan and gone straight out there. If we did have a copy of them in the UK, I'm afraid they would have gone into the skip at the Vision Park when Acorn closed down. Sadly, all of those drawings, our circuit diagrams, which were all carefully filed and kept until that day, to the best of my knowledge, I wasn't there by then, but to the best of my knowledge, an awful lot of that stuff just got put in a skip. So I think it's unlikely, but other people may know better.
I don't know if we've got time for one more question.
Go ahead.
Well, as there's no others in the list, this one was one of mine. So my question was going to be: there are other Eurocard type machines in the market at the time,
right?
And do you recall anything around what was better or perhaps worse about the systems range compared to its competitors at the time?
Yeah, I think it was John Thackeray earlier that said we didn't really ever need to look at other products because we were always pretty convinced that ours were best. We never saw any other products, be they computers or systems or Eurocards, that we thought were better than ours because of the architecture, the way we put the software together, and the quality of our designs. There was another company in Cambridge called Control Universal who built a similar range of products, and I think they were perhaps a little bit more commercially minded with their system products, because we were already moving on to the Atom and so on quite quickly. So they may have had in some ways a better go at Eurocard business, and I expect some of their products are still floating around, or documentation on the web. Control Universal was the name, and we were kind of partnered with them. I think some of our cards went into their systems. Some people would buy the basic compute from us and then go to them for other auxiliary cards, and they had their own compute cards as well. But there was enough business for everybody, so it never really felt like competition particularly. They're the ones I can remember. There may have been others. Right, so the Proton. As I said, Lisa was born at the end of November, 23rd of November. And then the Proton was born pretty much the same time. So these notebook pages of mine are dated 13th of December. Sorry, I've got a screen over on my left here. And I don't know whether you can read them, but the left-hand one says Essential Specifications. And then the other two pages, there were a number of pages in the notebook, but these other two pages capture the two essential ideas. The dual processor memory map with what's called here a channel between them. Obviously, we hadn't thought to call it a tube. Of course, it had to be a tube because it wasn't a bus. We hadn't, but we'd thought of that because that was how we could build an I/O processor, but have a gateway to 16-bit compute, which is where we knew the world needed to go, but we just weren't sure quite how yet. And then the other, the right-hand page shows the multiplexing of accesses between the CPU and the display controller into the DRAM. That was something that Steve had already proved on his homebrew system and that to me was the invention, the biggest innovative step in the BBC Micro. I would never have thought of it. The most memory cards that you saw would actually stop the DRAM memory system every 2 milliseconds, I think it was, and then run around all the address lines to make all the DRAM refresh, and then they'd let the processor run again for another 2 milliseconds. And that was how refresh of DRAMs was normally done. But the idea of using the raster to refresh the DRAM at the same time, and then organizing a difference between the logical address and the actual physical address in the memory, such that the display was actually striped through the physical memory, so that you got round enough addresses even if you were in a quite small display mode. And that's that funny piece of logic somewhere on this circuit diagram. Well, I won't find it quite now, but that's a hard piece of logic to understand. That all came from Steve, and it's what makes the machine. And you know, and he is rightly acknowledged with being its father. Steve went away over Christmas then and wrote this specification. I don't know if this has got out into the wild yet, or if this is, or I've got the only surviving copy, but it'll be in the box for you, Jason, anyway. And I guess this is Sophie's comments on it. It looks like her writing. And you know, we were starting, and then the BBC called. I mean, I don't need to restate the story here of how Chris found us the project, or how Herman and Steve persuaded Sophie and Steve that we could get the prototype done in time for when they visited on, I think it was Friday the 20th of February. Or how Herman cut a wire to make it spring into life. You know, this is all well documented. What I could say is I think these are probably the wire cutters that were used to cut that wire. And I don't think it was a clock wire. I think it was a power supply wire, but anyway. And by this time, of course, 4A was very busy. I personally couldn't join some of the overnight prototyping sessions. As said, we've got young children as well. But I would have had a big hand in sort of getting all the bits together, and moreover, the market square was so full that I gave up my office, and so my office was commandeered, and that was where we set everything up on my desk, and that was the room that the BBC guys all came upstairs, and to some people's surprise saw a working demonstration of graphics on the screen, which was considerably improved during the day once it had sprung into life earlier that morning. The picture on the right isn't actually from that day. It's a few days later, because the prototype seems to, Proton has grown with another board on the side. That's Alan Wright in the background, Steve, of course, turning round. And I don't think we know still who the chap is with his back to us. So if anybody can identify him, Steve and I would like to know. What's interesting to me is pinned above them is a circuit diagram, which is an early version of the one behind me. I almost certainly drew that, and I think what's happening there is that the bits that are populated are the bits that aren't shaded out. So the bits in the lighter part of the circuit diagram are what's on the board. So that's as much as we actually built for that prototype. The heart of the machine, the processor, the memory system, the video display controller, a version of the video chip, video ULA, but just sort of some basic modes done in TTL, and that was what was demonstrated. And then the week after the BBC visit, well, I became fully engaged with it. I was in meetings with their team, working with David Kitson and Richard Russell from BBC Engineering, mapping out the product and everything that needed to be done. And for the next few months, I owned the circuit diagram, which I took care to draw in a logical way to correspond with the physical layout of the PCB and the connectors on the front or the back, and therefore the two sides of the diagram. We had to make sure it fitted in the case design, which again had come from Alan Boothroyd. And one of the things that, one of the things, sorry, somebody's sending me messages. One of the things that I think helped us to win the contract so easily was that Alan Boothroyd had actually produced very, very quickly a mock-up of what the case design would look like in the same time scale as we were building the wire-up prototype. And I think that too impressed the Bee, because they saw a form factor of a product that they liked, compared, for example, to the new brain computer. We realized that there were going to be issues with component density, that it wasn't all going to go in, and early versions of the diagram grew with more and more logic, where the cassette interface was, the UARTs, the different video modes for generating pixels, and the color palette. And then we started drawing lines around part of the circuit and saying, well, we need to put this in a custom chip. Steve was still finishing his PhD, as we've said. So an awful lot of this design in many ways came from me, but it's all based on things we'd designed before. So if I look up, for instance, at is that the disk interface there? So, I mean, that's the disk interface, you know, from system products before that. Steve originally chose the 8271, but by the time it gets to here, this is more a case of me designing this and then Steve having a look at it one lunchtime, and I'm saying, well, I've done this like this. Look okay to you? Yeah, that's going to work, you know, and so it went on. But meanwhile, the heart of the machine down here, the 81 LS95s and so on, you know, that bit's absolutely Steve's. I stitched in the SAA 5050 and worked out, we were playing with phase lock loops at first, but I worked out this nifty little logic circuit somewhere that manages to build a 6 megahertz clock for the 5050 out of the 16 megahertz clock. I think it's described in the service manual how that works, you know. Sideways ROM, Econet interface over there, again, you know, as per systems, as per atoms. I expect I made a few changes. But essentially, you know, that's my circuit diagram, my design, based on Steve's architecture, and what we decided needed to go into the two ULAs, wherever they are. Can't immediately see them. And the ULAs then became Steve's domain, and we were fortunate there that the ULAs had already been used a lot in the Cambridge Ring hardware in the university by Andy Hopper and his team, and that was how we decided to go with them, and what gave us the confidence to use them. And Steve went off and worked with Andy and I think other colleagues in the lab who supported us to get the ULA designs done, and you know, I carried on with the rest of it. And I had three wires, a couple of wires up here. They were address lines for a block, 256 bytes of address maybe, and I needed to get them from over here to over there on the circuit, and there wasn't a clean way to draw them. So I put two arrows on them over here and ended up over there. And I think I probably said to Sophie, what should I call these? And she said, I don't know, Fred and Jim. So they got labelled Fred and Jim, and I think I added Sheila at some point later for no good reason. And sorry, it was what an opportunity. I mean, I could at least have called them Chris, Steve and Roger or something, but there we are. So that's enough of that. More notebook pages, an early guess at the chip list, delivery date promises from Ferranti for ULAs, obviously in a meeting in August of 81. I remember, and you know, I was really busy then. I mean, I was charging around, I was getting the prototype case moldings, driving the PCB layout, getting all the bits together. You know, there are components here like the, you know, what the quad A to D converter, did that come from Toshiba or somebody? You know, I was choosing that and getting the samples and sorting out all the connectors and all kinds of stuff. So there was a great deal going on, and the BBC were very supportive of all of this, and hopefully could see enough progress from us through David Kitson's monitoring that we were going to get a home run with this, which we did. The red brochure announced the product to the expectant public. The diagram in the red brochure I drew. I didn't draw that version of it. I drew it out on graph paper, and somebody went away with it and gave it to a graphic artist who produced this this brochure. One observation I think I'd make at this point is there were many parts of the design I wasn't happy with. I would have liked to have made something that was a little bit more expandable, with maybe what in later years Archimedes products had podules and things like that. And I had a hankering to do something that was a little bit more engineering-like. You know, we wanted something that looked more like the Atom and a consumer product as well. And there wasn't time to spend a lot of effort thinking what else we could do. But when I see the efforts that people have gone to fit butterfly boards inside and things of that nature, I do wish I could have made some kind of internal socketing as well for those kinds of things, but there just wasn't time to do all that stuff. So it had to be what it had to be. I think we all know that the Japanese memories were a very important part of the Beeb. The Hitachi account manager committed, they were one of the first to market with these high performance memories. And we got really, really good support. They shipped us parts over for the prototype. Couldn't have built that prototype 6 months earlier because we wouldn't have had any DRAMs available that were fast enough or could work off a single 5-volt supply. So it really was, you know, a critical enabler, the right components being available at the right time. And I remember some of the early samples, perhaps to build up, you know, the next 2 boards after the first wire wrap or something that were being delivered by a motorbike courier to my house on a Sunday evening, so we could take them in on a Monday morning, that sort of thing. We had wonderful support from a lot of chip vendors, Hitachi in particular, and we wouldn't have got where we got to without them. And then Tele software started almost immediately. It was a key part of the discussion from the get-go. So these notebook pages are dated March 81, so it's just a month later. And you can see we're with Mel Pullen, who I think is going to be speaking if ever I get around to finishing. And we're learning how teletext works and which other parts from the Mullard chipset we might need. Another meeting down at Kingswood Warren with Herman as well to make sure we were committed to the teletext adapter. And again, some of that design I had a little hand in the very early days, but folks like Mel took it over, and others, I think, Simon Rain, Graham Toll, a number of people contributed to that, and getting the tele software adapter done, ready for transmissions to start a couple of years later. As I said, the year was really, really busy for me, pulling it all together. I was recruiting people, working out how to get 12,000 machines built. Initially, we were going to go with ICL in Kids Grove, but for various reasons that didn't work, and then we engaged with a company called Cleartone in South Wales, who were more flexible. You know, managing these contract electronics companies, manufacturing partners, is complicated, takes a lot of effort. They've got people, they've got machines, but you have to tell them what to build. And they're going to build exactly what you tell them to, right first time, even if you told them to build the wrong thing. So you had to be really, really particular in all of the documentation and all the build instructions and everything you handed over to them. This notebook page seems to be me sketching out with some of the people from Cleartone what the production flow of final assembly and test and out of the door might look like. And you know, this diagram, I put this picture together just to really emphasize the point. If you look at my LinkedIn, you'll see that Steve has given me a recommendation a long while ago, who says I was a great colleague who knew how to get things done, because that came from my experience of working at Pi Unicam and Pi TVT, where we, as design engineers, we worked through a drawing office and we were driving manufacturing. And I understood how many different kinds of drawing and document you needed to fully capture and communicate a design, and with a, you know, as we said, a methodology for numbering and revisions, and all the different documents you needed: change control orders, concessions, build tracking, bill of materials, approved vendors list. You know, we couldn't use just anybody's chips. Somebody walked in with a 74LS245 and we'd never heard of that company before. We had to plug them into a board and put a scope on them and prove that we were happy with them. Bit of freezer spray, bit of a hot air gun, make sure it stood the test before we'd approve those parts and add them to the approved vendor list, allowing the manufacturing partners, purchasing people to buy them. So, you know, all of this was my domain. I'm doing it all for the first year or so, doing pretty much all of it myself. Had a lot of help with people like Glyn Phillips, who worked for us, and he produced the PET and the FIT test equipment for use on the manufacturing sites. And Cleartone started production in November '81, and by the end of June we built just under 23,000. So we quickly doubled what the BBC had asked for. And then in the 12 months following, from June '82 to June '83, I think we produced 120,000 machines. So we were selling up to 10,000 a month on average. In fact, I think we got to, at its peak, I think we were doing 5,000 a week. Now, first production then was what people today might call a minimum viable product. You know, the early issue PCB still had bugs to be ironed out. There was the linear power supply that barely coped with a fully populated micro without overheating. A case that was built in a softer plastic produced in a cheaper and an easier to machine molding tool. The sparkling for anti-ULAs, and the preliminary version of the machine operating system in EEPROM. So there was a lot to do, even though we were in manufacturing. And in addition to the work on the MOS-ROM, of course, that John described earlier, I pretty much had design authority for all aspects of the hardware other than the insides of the ULAs. And so I carried the circuit in my head. I knew where every part went. Had a team of people around me by then, and we quickly moved the PCB through the early issues to issue 4, sorting out some tracking errors, particularly around the printer port, as I recall. And then finally we got to issue 7 with some improvements to flow, solder, yield, and a better fit onto a bed of nails test equipment for checking out bare PCBs for shorts and opens before they went onto the production line. We ramped up another production site at Wong's Electronics in Hong Kong. So I traveled there a great deal in 1982. We tooled up a new version of the case in hard plastic, hard ABS, which I'm sure a lot of you have seen, the better quality cases. You know, the earlier ones have gone a bit yellow. I went out to VLSI's fabs in McKay Drive in San Jose with a BBC in a suitcase, and plugged in the first CMOS gate array replacements for the ULAs, and was able to sign those off there and then so that they could get those on the production site straight away. We were under huge pressure at that point to get that done, as you might imagine. It turned out the first ones had got a bug, in that, just a simple bug, that the mode 7 cursor was inverted. But I worked out on site there that we could cut a link and solder on a wire to invert it elsewhere. And so I signed off that they could go ahead and package up and finish fabricating, package up and send us the rest of those parts. And we would make that fix on the PCB to accommodate that, that one and only error. And then there was replacing the power supply with the switch mode supply. There was initially some resistance to using a switch mode supply, but we went for it, and I went out again to Aztec's factory in Hong Kong with a Beeb, and they gave me some samples and a scope and some meters, and I sat down in a room for an afternoon and played with the supply and decided it was okay, and again pressed the button to get those shipped over to our factories. I suppose one of my favourite stories, I remember being in Hong Kong with some shots off of the new case moulding tool. And I was there with my calipers. Again, it would have been these. These are the same. You only get one pair of these per life, don't you? And I was measuring things and looking at the fiducials on the PCB and saying, no, this isn't quite the right place. Why is this here? And so on. And we identified sort of 3 things on the case moulding that needed to be changed. And their response was, okay, no problem, we'll fix it. And they did. The next day, they went off, they got the tool off, they got it on the machine, they changed it, they did some welding, some milling, got the tool back up, filled it with hot plastic, and I went back in the following day, and mid-morning they turned up with some still warm case mouldings and said, is this better, Mr. Turner, Sam? And it, well, not Sam, it wasn't Japanese, and it was. So I should have pre-warned you, because I think questions are next. So that was, you know, a real whistle stop of what happened. I think just from the pace of that and everything I've had to put into it, you can probably sense what a busy time it was in 1981 and 82. Shall we take one burning question, Jason, and then I'll try and get the last bit done in 10 minutes.
One burning question. I'll pick one then. You asked for it.
Yeah.
So, why only 8 colours, and why later keep 8? I suppose that's in reference to the master and so on later after the B.
You mean a limited colour palette?
I'll take liberties with Richard's question, but yeah, even though it says like mode 2 is 16 colours, it's really only 8. The other 8 flash.
The reason it's only 8 colours plus flashing is because that's either on or off for each of the 3 colour guns.
Fair enough in 81, but what about, was any consideration for a wider colour palette given around the time of the master? Because obviously that was some years later when certainly other machines were coming through with more palette.
I'm sure it was, but I wasn't involved in those kinds of decisions for the master. As you'll see in the last part, at the time I was off elsewhere doing other things. I was also more of an engineering manager than an engineer by then. So that would have been a discussion had by possibly Steve and Sophie, Jeff Vincent, Paul Swindell, John Thackeray, and you know, all the other people involved in determining what the master would be. Just a few remarks about the history of what happened next. Well, the end of 81, we breathed a sigh of relief and moved to the water building in Fulbourn Road, Cherry Hinton, that we took over, and the water company no longer needed it. They had been doing processing of water from the reservoirs on the top of the hill behind us, but the building was redundant. We took it over and installed a mezzanine floor and built offices inside it and moved in. And it was a good building. It had character, you know. It was very cold in the winter, but no, we liked it. It was definitely ours. And you can see here a picture of me showing in my office in the water building before the silver building was built, with Kenneth Baker, the Minister of State for Education and Science. He was a great supporter of the project. I think I've been involved in, you know, signing off the Department of Trade and Industry funding for schools. And I think I'm showing him the new case moulding that's you know, just come back from Wong's Electronics, and we're going to start using those in production, and explaining why they're nicer than the fast time to market cases that we'd been using to date. Now, you might have noticed earlier on that there was an IEE logo, a lion, on one of the slides. So through all of this, I was also an active member of the IEE's local committee. You know, it's engineers getting together, putting on lectures, going to events, publishing papers and so on. The IEE, good thing. I was part of the Cambridge scene on that, and they asked me if we'd give a talk about the BBC Micro as part of their Michaelmas term programme in 81. So I think it was November the 18th, 1981. Steve, Sophie and myself, with one of the very first prototypes, went along to the engineering department here, hooked it up to a projector, and guess what? 500 people came, and there was standing room only. I introduced Acorn and the project. Steve gave a tour of the hardware, waving his arms around like this. And Sophie demonstrated the machine interactively, programming on the fly routines to paint graphics and show it off. Well, that was a huge hit. The IEE's headquarters got to hear of it down in Savoy Place. And we were asked to go down the following February and give the lecture there, which we went to do in the big lecture theatre. It was famously oversubscribed. They had to turn people away. People were asking where they could park their coaches and so on. And we went back and gave 2 repeat lectures, an afternoon matinee, an evening lecture a month or so later. And we then went on tour. The IEE organised and more or less funded a roadshow. All we had to do was turn up with some micros, and the 3 of us went to Coventry, Manchester, Edinburgh, Belfast, Dublin, and other cities. And I remember particularly we went to Cardiff and gave the lecture in a beautiful theatre with carved red dragons around the roof. And there were a bunch of guys all in the front row in suits looking at us. And they gave us their business cards afterwards, and they were from a company called AB Electronics, including the managing director. And we wondered why they were there. And then 2 days later, it was announced that AB Electronics had bought Cleartone. And it's pretty obvious why they were there. I think that was what made them decide to go ahead and buy it. I also remember a dinner with IE people in London, because there was always a good dinner and some wine afterwards, of course. And we were sitting around the table, and there was one really enthusiastic chap. And he turned to Steve and said, you know, talking about everything in the BBC Micro, and he said, "So what are you people going to do next?" Steve sat back and thought for a moment, and then he said, "We'll have pudding, I hope." And, you know, that was, yeah, I remember that. We all laughed. Very good. But these lectures, I think, were a huge piece of marketing, because I think they were very complementary to the sort of mainstream marketing that was going on, and the BBC's marketing. And I think with the thousands of people who came to these lectures, I think we introduced the BBC Micro to the country's engineering and science community. So it got picked up for a great many things other than just, you know, education and personal use and TV programs. And we really enjoyed doing them. We did them right through into the beginning of 1983, I think. So we had huge growth. We quickly outgrew the water building and all the porter cabins that grew up around it. We commissioned a new R&D building, which we filled immediately. The Silver Building, or the Greyhound Bus, or various other names. The building was built very quickly. It only had a 10 or 20 at most year design life. It's still standing today as one of ARM's buildings, and almost 40 years later. But I dare say it will fall down fairly shortly. Yeah, we all moved into there. You can see a couple of pictures inside what it was like. There's Ricky Rand at the bottom, and I think that might be the back of Dave Lampkin's head at the top. Maybe someone else can confirm or otherwise who sat up at that end. But that's where we were. That's the building that the first arm was lit up in, and so on. For me, 83 and 84 were really challenging years. There was a lot going on. As chief engineering manager, I was managing a large chunk of the R&D department with the help of group leaders like Alan Fournier and Dave Dickin. Overall R&D staff ran into the hundreds, many of whom I interviewed and recruited, including ARM founders as well. And we were dealing with new products like the Cambridge, the Acorn business workstation, the Electron. And, you know, people have talked elsewhere, Steve previously and today, about difficulties with the Electron ULA, which delayed its introduction and lost its market window to a large degree. From my point of view, the toughest thing going on was getting the US version of the Beeb, or the B Plus as it then was, done, because we'd never had to pay attention to radio frequency interference from our products in the UK. It wasn't regarded as important. But the FCC in the US, if you wanted to put something into people's homes, you had to meet their Class B compliance. And there was also Underwriters Laboratory safety compliance for safety and flammability. So we had a great deal of, you know, real nuts and bolts engineering to do. And the challenge, of course, was that Beeb had so many interfaces, and the FCC requirement was that you had to have everything connected when you measured it. You had to make a worst case measurement. So we had to actually take these BBC micros and hang a cable, a 1 meter cable off of every port, stretched out with something connected. The thing connected to it could be passive, just terminators, didn't have to have another product, kind of. And although there were things in the fine print about overall systems, if you had second processors and so on, but the thing radiated like hell. And so we had to introduce all this metal cladding and shielding and stuff. It was horrible. The thing is, if you were going to design a computer for operation in the US in an FCC Class B environment, you wouldn't start from where we started. That would be almost the part of the design that you started with from the get-go. But we did finally get there using a test lab in California, and we got the thing into a marketable state. I had a colleague called Richard Hughes who understood this stuff. It was very good. Unfortunately, it wasn't a commercial success over there, but that's perhaps a story for another time. Another anecdote, though, was that we did a lot of these radiation measurements on the grass on Acorn site at Cherry Hinton out beside the Silver Building. You had to be outside because we wanted to be well away from other radio emitting sources. And we had the Beeb, the unit under test, on a table with cables strung up in the air on poles of wood or something. And then 10 meters or so further back, we'd have a spectrum analyzer with a very fancy looking antenna that had a very wide polar diagram so that you could scan and get a spectrum of the radiation coming from the product. And that was how we sort of did our development before we went off to a test lab to get the thing signed off. Well, the bungalows, the residents of the bungalows who were behind Acorn's site actually complained to the council, and we had council inspectors coming out because they were convinced that we were either calling in UFOs or potentially exposing them to damaging radiation. So of course we had to reassure them that this wasn't the case. But what made me smile was thinking how similar that is to the scaremongering that went on about 5G just recently, and you know, everything that comes around goes around, and so on. So for me, at the tail end, as is known, Olivetti came in February '85. Acorn was downsized. We had a new CEO, Brian Long, who I got on with very well. I became operations director in our custom systems division that was run by John Horton, who'd previously been the technical director. We did things like the BT chain terminal so these were custom versions of Acorn products. The BT chain terminal, the Acorn communicator, a rack-mounted version of the book, BBC for Reuters, for their information systems and so on. And then they asked me to take on the BBC Doomsday project at the beginning of '86. So I was Acorn's project manager for Doomsday, basically pulling together all of our commitments for the video filing system. Thank you, Jonathan Griffiths, if you're still on. The Genlock, the interface to the Philips video player, the digital interface, pulling the whole thing together, working out with Philips how we could both sell systems, each contra-trading players and computer systems together, getting prototypes to the BBC in as timely fashion as we could to support the project. Lots of meetings with Philips and Eindhoven. You know, for a year there and marketing it afterwards in the early part of '87. So for a year or so there, I lived, ate and breathed Doomsday. I also became the company's eyes and ears on first generation CD-ROM and CDI, which of course was all of a related kind of media. And in '87, I attended I think what was the second Microsoft CD-ROM conference in Seattle, and visited Sony in Japan to look at their CDI prototype. That gave me a good sense of where the world was going with these media, which I brought back to Acorn, and was essentially, so I became the sponsor for, shall we say, the marketing sponsor for the development of the first CD-ROM interface and file system for Archimedes. But then that was not a lot more to do with me because I wasn't on the Archimedes team. So those were the last things I did at Acorn, and then there was another downsizing and reorganization. So I left the company at the beginning of '88 and gratefully joined the new Olivetti Research Lab with Andy Hopper. So that ended my time at Acorn. Here are the names from the MOS-ROM. Thank you to everybody who worked on that, and lots of people who aren't in the ROM but also contributed to everything we got done and I got done, and thanks to all of them. And as you can see, we were very proud that the Beeb won a Queen's Award for Technology in 1984, and for which I filled out and completed the application form, so had a hand in that too. I think you were looking at some of these pictures earlier. There's a picture on the left in 2008. I think that was after a do at the British Computer Society, celebrating some birthday of the BBC Micro. I won't run through all the names now, but I do know who they all were if anybody wants to know. And then the one on the right from the celebration held at ARMS offices a few years in 2012. We had a birthday party for Acorn as well, celebrate the 30th birthday of the formation of the company. There's Lawrence on the left, Sophie, Steve, myself and Herman holding a Model B board. Everybody turned out. It was quite remarkable. I think there must have been, we had a marquee in Cherry Hinton Hall. I think there must have been a couple of hundred people there, and we all met up, and it was like we'd never been apart, you know. It's great fun. Just finally, 2 more slides and then I'm done. Reflecting on all this, I've realized that we were designing in 1980 in a very much a golden age, I think, because if you think back, you know, 40 years earlier, say to when EDSAC was designed by Morris Wilks and Co in the computer lab, you know, that was a huge machine with all these valves, racks and racks of stuff, a whole team of people who had to put it together. And you needed to do all of that just to develop a basic computer. But then today, you know, when GraphCore produces its latest intelligence processing unit, I think it's called, we think of the $100 million they've spent, the size of the team, all the design tools they use, all the silicon fabrication infrastructure. Again, it's an enormous effort. And either way, what you realize is that never before and never since has there been an age for designers when people like Steve, Sophie, myself and others could knock up in our spare time something that really worked and had, you know, a useful technical impact that one individual could build. And I honestly think we were, you know, we were working in a golden age of individual design, where before and now afterwards, you can't do anything without a big team and a big organization. And I think that's reflected in the BBC Micro and how much people can do with it, how people can get useful and impactful results from it, without recourse to having whole teams of people writing massive programs and so on, unless of course they're games writers. And now, just closing on a sad note really, but I must here pay tribute to Alan Boothroyd. Alan was the industrial designer, as you know, who designed the cases for the Atom and the BBC Micro. And I worked very closely with Alan to get everything to fit, and sadly he passed this year. We owe him. He was important to us and we're grateful to him. And when we were just beginning to think about how to build the Proton, and there was this possibility brewing that the BBC might come to see us, Alan came in to talk to me about what it needed to look like, how big the power supply would be, how big the board would be, how many connectors there would be. And me, in my pedantic way, the only way I could think to get all the connectors, you know, all these ones on the back panel, but all these ribbon cables as well, I was thinking that we'd have to have a double deck of PCBs across the back with some connectors on the motherboard, and then a mezzanine connector to another mezzanine board with the rest of the connectors, which would have been, you know, a little bit expensive, a little bit clumsy, still compromised where the power supply needed to go. But that was where my head was at, and that's how I described the potential solution to Alan. And Alan said, yes, I see the problem, but that's not a very good solution, is it? And I said, no, but I can't think of anything else. And then a few days later, Alan came back and he said, what do you think to this? And he had the idea of thinking in 3 dimensions and putting the ribbon cable connectors at the front under the keyboard. And I hadn't thought of that at all. It's a simple and brilliant solution. And that came, you know, only from Alan, and we're grateful to him for it. So thank you, Alan. So that's the end of my Acorn story, and we're over time. So as has been mentioned, I'm happy to do a sort of fireside chat with more questions sometime if you'd like to.
How disappointed were you that Philips couldn't deliver the LV-RON drives at the originally projected price, making Doomsday Systems much more expensive than hoped?
Yes, they were a very commercially minded company. It was expensive technology. In all honesty, if you looked at all the bits that went inside, there was some justification to why it was so expensive. But the real whammy was not just them. The real whammy was that when the project was originally conceived, the BBC had had indications from elsewhere, government, that the Doomsday System might also receive 50% funding in schools. That didn't happen. I can't remember exactly why. I wasn't involved, whether there was a change of government even at that point in time. But it wasn't seen that the Doomsday System could receive 50% funding. And I think that that was a big disappointment to both us at Acorn and to the people at Philips. And bear in mind as well that in some ways we were a little bit tarred with the same brush. I mean, the master computer was not a cheap product. I can't remember what it sold for now, but it's probably 400 or 500 quid. Plus the Genlock board, the tracker ball, the video filing system. So I think our part of the package was, I can't remember the figure, but I'm guessing finger in the air, our part of the package was probably £800 or more. You know, and then the BBC wanted a couple of hundred for the discs or whatever. Philips wanted £3,500 for the player, and so it turned out to be a £5,000 system. Yeah, and I think we all knew that. The other thing that was happening, of course, was that the vision of laser discs had been very popular for these interactive video applications, but as the project was in its concluding phases, all of this new activity with CD-ROM, the High Sierra standards, Red Book, Yellow Book, and so on for encoding data on CD-ROMs was all happening. And CDI, Philips really went big with Sony on CDI, and the big, you know, there was, shall we say, disappointment in many circles that at almost the same time as Doomsday came out, Philips were busy pushing CDI. No, it couldn't have done what Doomsday did. I think I worked out you'd have needed 22 CDI discs to get Doomsday onto that media. But, you know, that was the direction of travel for Philips. So I think they probably changed their attitude to the Doomsday system in over the course of the project. Of course, it was, you know, a wonderful thing, but demonstrative really of what would happen on the internet not many years later, but just a thing at a point in time, really.
Regarding the US Beeb, I believe it lost quite a lot of money for Acorn, and basically, do you have a recollection of the approximate R&D stroke production costs, and really why the US Beeb was overall so costly for Acorn?
Okay, well, obviously we spent money in doing it. I'm not sure we had a project accounting system such that we weren't all filling in timesheets and things like that. There were often discussions about whether we should, but it wasn't realistic because, you know, R&D was such a holistic thing. For sure, we spent money traveling, test houses, time, materials. A lot of it rode on the B+, but as John mentioned earlier, there had to be a 525 line version of the video and things. But I don't think that was the major cost at all. I think the major cost was setting up the American office, staffing it up. We recruited good people, you know, with a track record. We recruited a dealer network, you know, in advance of having the product, but with samples of standard UK product or something. I think there was an initial marketing campaign, some public relations work, maybe even some pre-advertising. And overall, I would suggest that probably more of the millions of pounds that project cost us, I think more of those millions were spent through the American office costs than was spent on the research and development, which I struggle to think that would have been more than £1 million at the most.
Okay, we've got some questions coming in quick and fast. There we go. Quick question for Chris. The original Proton spec said RAM at least 48K, and then it just simply says, what happened?
Well, we wanted to get a couple of ROMs in as well, didn't we?
The Jim and Fred interface, Jim stroke Fred interface, was that supposed to be a device select at SCFF, like the M5000, that might be the Music 5000? As many implementations do just I own Jim and page into 64K. I'm reading that verbatim, I'm not sure. Shall I read that again?
Well, I'd have to remind myself of the memory map now, but overall, these were the tour spaces where all the hardware lived, weren't they? And so they were blocks of decoded address for hardware.
All right, and I think I'll just throw in one last one. perhaps referring back to the beginning of the talk, but here we go. So how did the Acorn atom end up in Canada? Brackets, Global Electronics sold it in Toronto. Do you know how well it sold? I had one, says Walter.
Yes. So I think rather like Australia, as Brian was describing earlier, Canada was another country where we had a local company who was keen to work with us on our products. And I think that came about partly because there was another company around called Torch Computers. And I forget what product they had in the early days. But there was some connection with them and Canada, and that enabled us to make contact, good contact in Canada in the same way that we made in Australia. And so there was another company like, was it Barson Computers? Forgive me if I've misremembered that name, where Brian was. So there was another company like that in Canada who were taking atoms and moving a few locally for that local market. And I think as far as electrical safety is concerned, well, of course, electrical safety wasn't an issue for the for the atom, because like the System 1, it had an external block, so all you needed was a 110 volt version of the transformer, which they probably got done locally. You know, with the FCC stuff, well, I expect they were just, if that was even relevant in Canada, they were probably just flying under the radar. But yeah, so there was another distributor over there.
Okay, I think that probably ought to wrap things up for this presentation now. But just to say, Chris, thanks so much for that presentation. It was incredibly informative, and some of the slides there certainly lit my eyes up, and I'm sure some others too. With I guess some of the artifacts from way back then. These are sort of like golden bits of history to us on this forum now. So very much appreciated, Chris. Incredibly well structured and well put together, just like the BBC Micro. So thanks very much, and yeah, great. Cheers.
Okay, well, thank you very much for giving me the opportunity. And as we were saying earlier, many of us really do appreciate the continued interest in our work, and you know, it's very pleasurable for us to see see events like this still going on, and see the support that we get, particularly from the Computer History Museum. So thanks everybody. Thank you.
Thank you, Chris. Yeah, just another quick plug for Centre for Computing History. If you're able to, or you feel you're able to, you can donate via the Just Giving page, or as it says, there are other ways to help, including, as you saw some of the slides in the break, you could buy some of the items from their online gift shop.